Hello, hello, hello. So in the last video, we basically looked at how to run applications inside Docker. We built a small example using Node.js and PostgreSQL. And now we are going to move on one step further to dive into the Kubernetes world. So basically, Kubernetes is some sort of clustering, and you can run your Docker containers in there too. So the word Kubernetes comes from the Greek word and means something like helmsman, pilot, or governor. It was designed by a few employees from Google. Most of them recently worked on Borg, which was the previous version. From my understanding, Borg was written in C++, and Kubernetes was basically written in Golang, which most likely makes development much easier and faster. And after Google open sourced it, they basically passed it on to some foundation, and they now run it as a open source project. And it has picked up quite a lot of activity on GitHub, and people keep on using it more and more. I think it was written or published in 2015, so it's now 5 years old, and it now has reached version 1.19. So simply put, Kubernetes is a tool for managing and automating containerized workloads in the cloud. So the cloud could be some big cloud like Azure or AWS or Google Cloud, but you could also just run your own little cluster. What you do is you define your desired state of your application, and Kubernetes then ensures that all parts of your application are in that desired state. You basically feed your deployment YAML file, which is similar to the Docker Compose we built in the last video, and send that over to Kubernetes. And then the Kubernetes cluster services make sure that the containers are running the way you define them inside your cluster. It does work across multiple machines. So a machine in Kubernetes land is called a node. And the heart of Kubernetes is known as the control plane, which are the so-called master nodes. They have an API endpoint, and then you have different services running there. For example, etcd is like a key value storage, and Kubernetes uses this to store information about your cluster. So there are basically two types of nodes that you have: the master nodes, and then you have the worker nodes. And the worker nodes basically run just containers. Each of these run also kubelet, which is a small application that basically talks to the API and then carries out the tasks on the individual nodes. And then we would also have pods running on the individual nodes. Pod is basically, you can think of a pod of whales, and each whale being a container, which then in turn form the pod. So basically, a pod is the smallest unit you can deploy in Kubernetes. As the workload of containers increase, you can also scale horizontally. So you would add another node in there, would link it to the master, and then it would start scheduling tasks on that node too. Kubernetes also takes care of networking between the containers. It manages secret management, so you can store passwords in an encrypted way. And you also have the ability to mount persistent volumes. So containers are known to be ephemeral, so you basically run it. Whatever is written inside the container will be lost once the container shuts down, and you can avoid that by mapping volumes to your containers. Okay, I think the next step, it might be quite confusing to get started, but I wanted to start by talking about the different parts of Kubernetes. Well, the most commonly used ones. So as we already said, we have the nodes. So nodes can be worker node or a master node. Then we have the pod, which is the smallest deployable unit. I did create a page here where you can see a few examples. So basically, a pod is a small little definition of the kind pod. You give it a name, you give it a role, and then you specify the image.
The image is basically the name of the Docker image that you can run. And then you can also give some more information like which ports to expose. So in this example, we are running a Nginx server and we are exposing port 80 as a type of TCP. So then you might think if you have pods running and they are ephemeral, so they can close and be restarted, how does Kubernetes manage the routing of traffic to these pods? And this is where services come in. So basically a service, you can think of something like a load balancer sitting in front of your application. And if your pod goes down or the container restarts, then the service will remain up and running, and you can then it would route traffic to the container. Once it goes down, it knows, okay, that is now down. Now I need to reroute traffic to another container that has been started up. So there are two types of service. There are more types, but the most commonly two are the service with the type of load balancer. That would basically make the service available on all cluster nodes. So you could, we'll get more into detail on that. And then we have the internal service, which only makes it accessible from other containers. The next module would be a Ingress. Ingress is a sort of way how external traffic gets routed into our cluster. So, for example, this would be a HTTP ingress. So some HTTP request comes in, it goes to the /test path, and then it knows to which service to route that traffic to. So basically, traffic comes in, hits the ingress, and from there it gets routed to a service, and the service then would route the traffic over to the pod. And as part of the pods, we have the containers which then actually process and do whatever needs to be done. We then do have a config map. So a config map is a little bit similar to Docker Compose, the environment sections. So you usually use that to store some sort of environmental variables. And you can then use these to map them to containers and then access the environmental data from within the containers. Secret is pretty much the same as a config map. The only difference is that one would encrypt the stuff. So for example, here I am using the password from our tutorial, and I just base64 encrypted, have that value, and then we would store that in here somewhere. Then after that, we have the volumes. So like I said before, the Docker image that we run doesn't really have persistent storage, but you could map a volume to a container and that way keep persistent storage. What you can also do is you use a config map as a volume, which is shown here. And that allows you to basically mount different config maps to different containers. So if you have, let's say, 20 web application containers and they all need to read from some database, you would create a config map and a secret and would store your information about the database in there. And then you would mount that config map to all your web containers. And all the web containers then can read the information to which database to connect to, which makes it quite dynamic. Okay, then we also have a deployment, which is an abstraction layer that defines the creation of pods, but also includes replication for convenient scaling and updates. So this way you can run containers on multiple workers, improving the overall uptime. You pretty much would use them for everything except for applications that require persistent storage, like databases. For these, we would use stateful sets. So an important part of a deployment is the replication. So in here, we have our containers. Again, we have a Nginx container and we have port 80. And here we define a replica of 2. That means at all times, Kubernetes desired state is to have 2 containers running of that. And that is what you should usually do for everything that is sort of important, because Kubernetes is known to be ephemeral and containers just die and get restarted somewhere else. So if you always have multiple containers running, it doesn't hurt your application if one of these goes down, because there are others that can take over the work. Yeah, and then we do have a stateful set. In this example, just a simple example with Nginx again. And stateful sets is something you can use if, for example, it's used with databases like MySQL or PostgreSQL, Redis, MongoDB. It gives you more options to define in which way to restart and the order to restart in, and it makes sure that, yeah, that basically you need that stuff to run persistent databases. Yeah, that is pretty much for the introduction. And in the next part, we are going to start installing or setting up a small k3s cluster. And then we can basically dive into all of these different components more in detail and get our hands dirty. Okay, speak to you soon.